Alright, this is 2010 AP for response number 2. So a student performs an experiment to determine the molar enthalpy of the solution of urea, and he places 91.95 grams of water at 25 degrees Celsius in a coffee cup calorimeter and immerses a thermometer in the water. And after 50 seconds, he adds 5.13 grams of solid urea, also to 25 degrees Celsius, to the water, and measures the temperature of the solution as the urea dissolves. So the graph of it is shown below, and the starting temperature is 25 degrees Celsius, and at the end of the graph it reaches a temperature of 21.8 degrees Celsius. And the first question says determine the change in temperature of the solution. So that's finding delta T, which is T final minus T initial. And so it's 21.8 minus 25.0, which equals negative 3.2 degrees Celsius. So that's part A. So for part B, it's asking if the dissociation is endothermic or exothermic. So you can tell by looking at the graph that since heat is being lost by the end of it, since it starts at 25 degrees and ends at 21.8, the value is negative, which means it is an endothermic reaction. Alright, for part C, it says, assume the specific heat capacity of the calorimeter is negligible, and that the specific heat capacity of the solution is 4.2 joules grams Celsius. So to find the heat of dissolution, you use Q equals MCAT. So you do NQ equals, and you get 1 point for just setting up the problem. And then you know that the M is 5.13 grams because that was given to you at the beginning, and you know that he also places 91.95 grams into water as well. So you know the total amount of grams is 97.08. And then to find Q, you just plug into the equation. So you know 97.08 grams times 44.2 joules per gram Celsius times negative 3.2, which was given to you as well, is equal to 1.3 times 10 to the third joules, which is your answer for part B. Part C. And then it also says find the molar enthalpy, which is delta H. And so you know that delta H equals Q over mole solute. So first you have to find the molar mass of H2NCO and H2, which is 4 times 1 plus 2 times 14 plus 12 plus 16, which ends up to be 60 grams per mole. Right? And then you know to find the moles of urea, you do 5.13 times 1. You know that there's 1 in 60 grams is 1 mole. So it gives you the molar concentration of 0.0855 moles. And then you go into delta H and you say 1.3 times 10 to the third joules over 0.0855 mole is 1.5 times 10 to the 4 joules per mole, which is the same thing as 15 kilojoules per mole. And then in part D, it says use the information to calculate the value of delta S, and they say delta H is 14.0, and delta G is negative 6.9 kilojoules per mole. So you use the equation, go home to supper. And you know that delta G is negative 6.9 kilojoules per mole, and 14.0 kilojoules per mole is delta H. And then the temperature is 298 Kelvin, because it says at 298 Kelvin. and then times delta S, which is what you're solving for. And so once you plug that in, you get delta S is 0.0701 kilojoules per mole Kelvin, which is the same thing as 70.1 joules per mole